Austria, en Graz, ¿ya? Es uno de los autores más prominentes en gestión de la innovación, de acuerdo a varios artículos. Es uno de los autores que ha generado un modelo de gestión de la innovación que está acorde a la industria 4.0. Y pues tenerlo como profesor del curso también es un privilegio. Él es mi mentor, y cuando le comenté la posibilidad de dar este curso, pues inmediatamente me dijo, César, hagámoslo. Y pues y si se matriculan, van a tener el gusto de conocerlo, ¿no? Claro, él va a dictar desde Austria. Y bueno, ¿de qué trata el curso? ¿Ya? Son 3 capítulos. El primer capítulo trata acerca de entender la innovación. Muchas veces tratamos o hemos entendido la innovación como novedad o solamente como algunas de sus características. Bueno, hagamos un ejercicio rápido, ¿ya? Tengo aquí un QR de Menti, ¿ya? Para ver una nube de ideas que puedan tener ustedes sobre la innovación. Les estoy poniendo que escriban 3 palabras que se relacionen. Pónganlas en inglés, por favor, para mantener la lógica de esta presentación. 3 palabras que se relacionan con lo que ustedes entienden por innovación. Solo 3 palabras. Y vamos a ver de qué se trata, ¿no? Pueden usar también el código QR que está por aquí. Hagamos este experimento. Siempre lo hago. En varias de las consultorías que he hecho en gestión de la innovación, pues el panorama es muy similar. Veamos si se repite también con ustedes. Ujú. Vemos ideas, desarrollo. ¿Qué más? 3 palabras. Tecnología, visión por computadoras, nuevas ideas, desarrollo, evolución, automatización, tecnología, avaricia, dicen. Evolution, evolución, progreso, creatividad. Qué interesante. Dinero, smart cat. Bueno, asumiendo que ya están dejando todas sus palabras, vean que ninguna de estas palabras está relacionada o están más sesgadas hacia la tecnología. Claramente somos un público ingenieril, siempre estamos hablando de tecnología, de creatividad, de estas cosas. Sin embargo, la innovación no se trata solamente de crear cosas nuevas, no se trata solo de tecnología. Tiene que ver con algo muy importante, sin lo cual no podemos hablar de innovación, y es el mercado. Bien, la tecnología está justo en el medio, somos ingenieros, ¿no? Y, tecnología, diseño, pero no estamos hablando del mercado, nadie ha puesto mercado. Y el mercado es fundamental porque si no entendemos la innovación como una idea que satisfactoriamente se ha implementado, tiene éxito, genera rentabilidad, alguien puso dinero por ahí, es muy cierto, tiene que haber dinero. Si no genera dinero, no es innovación. Podemos hablar de creatividad, de muchas ideas bonitas, muchas ideas fantásticas, pero si no llegan a construirse, si no llegan a implementarse en el mercado, pues no hablamos de innovación. Ese es el primer mensaje del curso. Todo el primer capítulo del curso se trata de herramientas para entender de qué se trata la innovación, de entender el mercado, de entender la tecnología y de entender también el proceso complejo de implementación. Porque no se trata de tener una idea y esta idea automáticamente se va a vender o va a ser aceptada. ¿En qué momento tenemos que patentar? ¿Cuándo tenemos que proteger? ¿Cuándo debemos optar por otro tipo de protección de la propiedad intelectual? Tiene mucho que ver con qué tan innovadora, y no innovación entendida como novedad, sino entendida como el valor de mercado que tiene nuestra idea o nuestra tecnología. Entonces, el mensaje es que sabemos todos, de que tenemos que innovar. Sabemos que tenemos que innovar, pero la pregunta es ¿cómo? ¿Cómo empezamos a generar innovación real? Innovación, recuerden, desde ahora llévense el mensaje, lleven o no el curso. Innovación no se trata de tener ideas, se trata de llevar ideas útiles al mercado y que sean rentables. Es una actividad netamente empresarial, ¿sí? Muchas veces decimos que las universidades innovan y eso está un poquito, estrictamente hablando, no es tan cierto, porque las universidades muchas veces están dedicadas a generar conocimiento, a generar investigación, y la investigación no es innovación. Y alguien va a decir, no, pero sí, nosotros sí innovamos. Claro, innova en el sentido de el diccionario de la Real Academia, que nos dice que están generando algo nuevo, pero estrictamente hablando desde la especialidad de gestión de la innovación, la investigación es una actividad completamente distinta a la innovación. La innovación es empresarial. Claramente van de la mano. Cuando uno genera conocimiento y lo implementa en el mercado y tiene rentabilidad, tenemos todo un ciclo de innovación y tenemos un país que progresa. Tenemos un modelo de desarrollo basado en pensamiento, basado en innovación tecnológica, en conocimiento implementado en el mercado y pues un modelo de desarrollo plenamente moderno, ¿no? Compatible con la industria 4.0. Y pues tiene que ver con la de física, tiene que ver con la parte humana. Nosotros como ingenieros normalmente vemos el desarrollo, el éxito de las tecnologías aquí, el mundo de la física, ¿no? La resistencia de materiales, vemos el control, toda la teoría que han visto en su carrera. Pero hay otro aspecto humano que tiene que ver con el mercado, tiene que ver con la psicología, con la antropología, cómo acepta las personas esto que han desarrollado ustedes, esta tecnología. Y aquí, en esta intersección, cuando lo posible físicamente, lo posible tecnológicamente se intersecta con lo que la sociedad necesita, con lo que el mundo está dispuesto a pagar, pues tenemos las condiciones de borde para la innovación y puede funcionar algo, podemos crear algo que tiene éxito y que finalmente nos va a hacer no solo sostenibles, hablando en términos de que nos van a pagar por lo que hacemos, sino también rentables para poder seguir investigando, seguir creando, seguir innovando. ¿Sí? Es un modelo de desarrollo súper interesante. Y recuerda, este curso no tiene que ver estrictamente con la carrera de mecatrónica, es algo más abierto, ¿no? Una idea general de lo que podemos hacer con la tecnología, con lo que ustedes saben en mecatrónica. Capítulo 2, ya entendimos qué es la innovación. Capítulo 2 tiene que ver con la gestión de la innovación utilizando el modelo de innovación Big Picture. Aquí entra el profesor Lerger, el autor del libro. Les voy a dejar los enlaces para que lean el libro, es gratis, ¿no? Lo ha publicado en internet él. Y este capítulo, pues, habla de la gestión de la innovación con un modelo de última generación. Es un modelo que ha salido en 2020, después de mucha revisión de literatura, que está siendo utilizado en varios países en Europa, en varias empresas bien grandes, de todo tipo, ¿no? Desde manufactura, servicios, ciencias de la computación, analítica de datos, de industria 4.0, ¿sí? Y él nos va a contar cómo es que está utilizando este modelo en estas empresas. Como consultor, incluso el Parlamento austriaco lo ha contratado para tener una nueva política de innovación para su país. ¿Ya? Es una persona sumamente eh, eh, actualizada, ¿no? Este modelo de innovación es muy bueno. ¿Y por qué gestionamos la innovación y por qué necesitamos un modelo? Porque miren estos números rápidamente. Normalmente en una empresa hay muchas ideas, todos somos brillantes, todas las personas tenemos ideas fantásticas. Sin embargo, no todas las ideas son buenas, no todas las ideas buenas en el sentido de que pueden generar rentabilidad. Y cuando hablamos de empresas, si no tenemos rentabilidad, pues, ¿en qué invertimos los recursos? ¿Cierto? Miren, de 1919 ideas, solamente 11 se convierten en productos exitosos, 17 con una ganancia promedio, 24 pérdidas, 124 productos o servicios que son rechazados por el mercado, 176 productos que han sido lanzados, 369 productos de directorio, no proyectos de directorio, de las 1969 ideas. ¿Tenemos dinero para invertir en todas las ideas de toda la gente en la empresa? Pues no, la respuesta es clara, ¿no? Los recursos son escasos. Y la gestión de la innovación trata de cómo obtener el mejor concepto, la mejor idea de todo ese pool de información de la gente brillante con la que trabajamos y lograr los mejores productos y los más exitosos que nos permitan sobrevivir como empresa. Y como les digo acá, los recursos son limitados. Y la gestión de la innovación es gestionar el riesgo financiero, ¿no? No todas las ideas son posibles y sobre todo el tiempo es muy, muy valioso y no lo recupera. Este es el modelo de gestión de la innovación. Vamos a ver cada uno de los campos, cada una de las grandes preguntas que están aquí representadas por estos colores medio transparentes, ¿no? La gran pregunta 1, gran pregunta 2, gran pregunta 3, gran pregunta 4. Todas ellas son fases desde un proceso de creación de la estrategia de una empresa, hacia dónde debemos ir, cómo debemos apuntar, cómo es que vamos a generar las ideas, cómo las vamos a gestionar una vez que decidamos qué idea vamos a implementar, qué producto vamos a sacar al mercado, y luego tenemos ya la parte final de una retroalimentación, un aprendizaje nuevo de los resultados que obtuvimos del mercado para volver a innovar, porque la innovación no se trata de un proyecto, no es lineal, es cíclica, es iterativa, es equivocarse una y otra vez, equivocarse ágilmente, equivócate rápido, equivócate barato, algunas veces les he dicho esto, y este modelo pues, nos permite abordar ese proceso caótico de gestión de la innovación con un enfoque sistémico, para tener una guía y saber por dónde debemos ir. Y esta es una frase del libro, es un proverbio árabe, ¿no? Cuando uno sabe de gestión de la innovación, pues se convierte en una especie de león que sabe hacia dónde ir, ¿no? Un ejército de ovejas liderados por un león podría derrotar un ejército de leones liderados por una oveja. Muchas veces en las empresas tenemos gente súper capa, pero que todos están yendo en diferentes direcciones. En cambio, cuando tenemos una clara gestión de la innovación, podemos ir y sacar productos, sacar servicios que son rentables, que nos hacen ser una empresa siempre actualizada y pues con buenas perspectivas para el futuro, especialmente en una época tan difícil como la que estamos viviendo, dado que hemos visto disrupciones por la pandemia y también disrupciones tecnológicas por la cuarta revolución industrial, la que justamente trata el capítulo 3. Ya vimos qué es la innovación, ya vimos cómo gestionarla, cómo sacar los mejores resultados en este entorno tan cambiante, y vamos a ver ahora en detalle de qué se trata hacer negocios y enfrentar la disrupción, y por qué no crear la disrupción con nuestros negocios en la industria 4.0. Vamos a ver los enfoques tecnológicos y sociales en la industria 4.0 en mercados emergentes como el nuestro, ¿no? Muchas veces se habla de industria 4.0 en Europa o en Estados Unidos o en Japón, pero ¿qué tal si le damos una visión desde nuestro punto de vista y cómo podemos aprovechar la tecnología para cambiar los paradigmas de nuestro propio mercado? Les voy a dar esta presentación, ya aquí hay un resumen súper chico de qué se trata la industria 4.0. Básicamente es que todo está interconectado ahora, ¿no? Ya no tenemos una gran revolución basada en el vapor o basada en la línea de ensamblaje, ¿no? Ahora todo está conectado y aparecen nuevas oportunidades, y las empresas están compitiendo ya a este nivel. Y también no solo las empresas, sino también las carreras de ustedes. Tenemos que pensar en industria 4.0. ¿Cómo vamos con el tiempo? Vamos si tenemos algo. No, no nos alcanza. Vamos rápidamente a continuar con la presentación, ¿no? Estos son los temas de el último capítulo, el capítulo 3. Vamos a ver Industria 4.0, cómo implementarla. Rápidamente las tecnologías, Internet de las cosas, Internet de los servicios, manufactura inteligente, dispositivos y productos inteligentes, ¿no? Sistemas y tecnologías para permitir que se establezca o permitir el desarrollo de la industria 4.0, sistemas ciberfísicos, computación móvil, eh, disciplinas relacionadas para la industria 4.0, inteligencia de máquinas, ciberseguridad, gemelos digitales, robótica. Claramente lo vamos a ver como una visión no tan de cómo implementar esto, sino cuál es el efecto que podríamos tener o cómo podemos innovar con esta tecnología. El rol de la data, del conocimiento, de la colaboración en las organizaciones. Recuerden, la innovación es la creatividad en acción, y puesta en la industria 4.0 es tomar a muchos aliados para crear productos cada vez más ágiles, cada vez más innovadores, y que el mercado responda, no solamente ya en cuestión de dinero, sino también de responsabilidad social, de cómo estamos afectando al mundo, cómo es que nuestras actividades tienen que ser cada vez más inteligentes para reducir el impacto que tiene la actividad humana o nuestra propia existencia en nuestro planeta. ¿Sí? Tecnología al 100% en este último capítulo, y vamos a ver también cómo conectar la innovación con la industria 4.0. Requisitos, sí, tienen que saber inglés. Laboratorios. También este curso cuenta con laboratorios que van a hacer análisis de casos, y he preparado algunos casos para ustedes. Primero, la invención de los rayos X, que es una historia fantástica de cómo una innovación que prácticamente se descubrió al azar, pues tuvo un enorme impacto en la salud de las personas. Y no solo en la salud, es todo una historia genial de dónde salieron los rayos X. El segundo taller, o el segundo laboratorio, es utilizar el marco del modelo de innovación del MIT para analizar diferentes tipos de empresas y de industrias que han innovado en los últimos años. No vamos a hablar de cosas de los 90 o de los 80. ¿No? Esos enfoques ya no son válidos en esta época. Vamos a entender después, en los laboratorios 3 y 4, vamos a analizar el caso de Tesla. Desde las bases de cómo innovaron para revolucionar una industria muy tradicional, con grandes jugadores como los fabricantes de motores en Europa y en Japón, y cómo cambiar esta industria y también ser responsables con el medio ambiente. Claro, hay muchos detractores que van a hablar de las cosas erróneas que ha cometido Tesla, pero en general es una empresa increíble que está cambiando el mundo. Luego vamos a ver técnicas de gestión de la creatividad, básicamente cómo sacar las mejores ideas de un equipo de personas. Y luego vamos a ver un caso que se llama Street Scooter, que es una empresa que se creó en una universidad en Alemania y que ahora es parte del Deutsche Post, de DHL, y que ahora es una empresa que compite y está en bolsa, que se creó chiquita desde una universidad y ahora está compitiendo en el mismo mercado que revolucionó Tesla. ¿Cómo hacemos esto? Pues aquí hay una respuesta muy interesante. Y finalmente vamos a acabar con una de las empresas que ha crecido enormemente utilizando la tecnología, una de las tecnologías, que la conocemos todos, Rappi. No vamos a ver cómo hacer un pedido, sino vamos a analizar el caso de negocios y qué aprendizajes podemos tener de una startup de este tipo, que usa tecnología para resolver una necesidad que está en toda Latinoamérica. Ese es el curso en términos generales. En exámenes, 2, laboratorio 5, y ustedes ya conocen ese tipo de evaluación. Bien, quedo atento si es que tenemos tiempo todavía, estimados amigos de ACIME, si es que hay preguntas. Voy a compartir el sílabo para que lo puedan ver.
Más bien, profesor Coasaca, muchísimas gracias por la ponencia. Creo que es uno de los electivos que más está llamando la atención y que sobre todo aplica sobre todo al mercado moderno, al mercado actual. Más bien, para pasar a la siguiente ponencia, pediríamos que puedan realizar sus preguntas por el chat de Zoom, y así el profesor Coasaca puede ir respondiendo mientras se realiza la otra ponencia. Muchísimas gracias, profesor.
No,
Quedamos
magnífico, Rodrigo.
atentos.
Muchas gracias. Espero verlos por ahí.
Muchas gracias.
Pasamos.
Okay. Okay. La siguiente ponencia que se va a realizar es acerca del curso de Advanced Dynamics del profesor Pedro Flores.
Hola, Pedro, ¿cómo estás?
César, ¿qué tal? ¿Cómo estás? Chicos, ¿qué tal? ¿Cómo están? Denme un momento, por favor, mientras me acomodo por acá. ¿Qué tal, chicos? ¿Cómo están? Muy buenas tardes con todos y bienvenidos. Como ven, estoy de vacaciones. Medio de vacaciones en realidad. Y bueno, gracias a la mesa directiva de ACIME por permitir estas ponencias, ¿no? Creo que son bastante interesantes para que luego puedan conocer un poquito más los selectivos a los que se van a matricular, o los que piensan matricularse en algún momento. Y no tengan duda de que cualquiera de los selectivos que elijan, pues de verdad que los va a ayudar, los va a ayudar bastante, les va a ayudar les va a dar otra visión en distintas ramas, en distintos aspectos de la carrera que quizá un curso obligatorio, digamos, teniendo que cumplir con algunos requisitos, pues no les va a dar, ¿no? Siempre los cursos selectivos es la oportunidad de los profesores digamos, para darles un poco más de ese conocimiento que siempre decimos en clase, ¿no? Siempre en clase estamos hablando de algo más acerca de nuestra experiencia, de nuestro conocimiento, de los campos de investigación que hacemos, ¿no? Y pues en realidad los cursos selectivos son un muy buen camino para darles este conocimiento, ¿no? Entonces, bueno, ¿no? Voy a compartir acá la presentación. Tengo... Ajá. Y listo. Bien, entonces, bueno, se puede ver la pantalla, ¿no? Confírmenme, por favor.
Sí.
Sí, listo. Gracias, Rodrigo. Perfecto. Entonces, genial. Bien, la presentación está preparada en idioma inglés, entonces yo voy a hacer la presentación en inglés también, para que también tengan una idea de, digamos, cómo lidiamos los profesores también con este tema del inglés, y que también van a, y también digamos un poquito el nivel, las cosas a las que se van a tener que enfrentar durante clase, ¿no? Así que como para que tengan un pequeño taste de cómo lo vamos a hacer. Sí, entonces de acá en adelante voy a hablar en inglés. Y bueno, al final las preguntas pueden ser en inglés, en español, sin problemas. Okay, very well, guys. So, this is the Advanced Dynamics course. This course is lectured by two professors. Professor Nilton Cuellar, he is a mechanical engineer. He works in Brazil. He works for a company that makes robots. It's a company that actually makes actual robots. So his knowledge is very practical, and he has worked hands-on on robotics, and he is very happy to lecture the course with me. So this course has two approaches, a theoretical approach and a practical approach, and that we're going to discuss later. But as the name says, the Advanced Dynamics course is designed to enhance your knowledge, your already rich knowledge on dynamics. We've worked, and many of you have worked with me in the dynamics course and the basic dynamics course. And we have explored some of the dynamics, but not all of it. And especially the part that concerns you most as future mechatronics engineers. And this is the 3D dynamics. So in this course, we are going to develop the expressions, the formulae that you will need to deal with robotics. And I know most of you, I know you will, most of you have decided for this career based on robotics, based on, for example, I don't know, many of you maybe have some vision of yourselves designing and building and manufacturing and testing robots. But to do so, you must know your dynamics. You must, as a matter of fact, know dynamics better than anyone. So this course is designed, as I have already said, to enhance your knowledge on the dynamics course. But don't worry, this will not be as traumatic Okay, so what about the course? The course is designed, as I've already told you, to expand the knowledge already acquired the previous dynamics course. And we're going to cover 3D kinematics, but I mean real 3D kinematics and kinetics. And there will be a special focus on robotics. Okay, so this shall be very, very special for us, because 3D dynamics is something very, let me say, very special. It is not the same when you do your so-called downwards principle, when you do 3D dynamics. It is not the same. It's not quite the feeling. And why is that? Because 3D dynamics, and let me be absolutely clear about it, 3D dynamics can be mathematically very, I don't want to say complicated, but I should say tedious to deal with. And to do so, we do not use analytical expressions. Although we are based on analytical expressions and on laws and principles, at the end of the day, we use computers to compute 3D dynamics. And that is what we are going to teach you. Because at the end of the course, you will be able to formulate and solve mathematical models that represent the motion of serial robots. The course has a special focus on robotics, and that special focus is on serial robots. Professor Cuellar works, designs, and manufactures serial robots in his company. And you will be able to simulate motion of such systems using MATLAB. We're going to take advantage of this mathematical tool that the university has given to you, the MATLAB licenses, which are free. The university has a campus-free license, so every single one of you must be able to download and install an official license of MATLAB in your computers. And we are going to take advantage of this license to represent and simulate motion using MATLAB. And let me be also clear about something. We are not gonna animate. One thing is to animate. One thing is to appear that the robot is moving. We're going to simulate. And simulation is quite another thing. When we talk about simulation, then we are talking about not just to see the motion, but to actually calculate some variables, some magnitudes that are designed to help us understand motion, that are there so that we can design the robot, we can design the pins, we can design the joints, we can design the length, we can design the geometric appearance of a robot just by calculating forces, torques, velocities, accelerations, trajectories, which are very important in robotics. So in the course, we will develop theoretical knowledge to calculate such motion, but you will also apply it. And you will apply this knowledge since the beginning of the course in a project, which you will develop throughout the semester. So you are going to have a hands-on experience on robotics. And let's hope that in a few years, maybe you will be manufacturing robots, and you will be working on robotics, and you will remember when you took this course. So the course has two, I would say, two stages. The first stage is theoretical, And the second stage is practical. So we believe in a theoretical practical approach when it comes to robotics. The course methodology, we, the lecturers, will present in detail the theory needed to study 3D dynamics using presentations and other computational tools. Besides MATLAB, the other computational tool that we use is Python, but not as a programming language, but as a symbolic language to help us deal with the mathematical complexities of the theory that we are going to see. So don't worry, the dynamics is cool. It seems complicated sometimes, but I promise you, it's very cool. So along with theoretical sessions, you will have lab sessions, and you will learn to use computational tools to simulate step-by-step real robots. We are not going to tell you that you can simulate all robots, because that would be a little bit ambitious. We will need almost a year or a year and a half to teach you how to simulate any robot, any motion. But we are going to focus on serial robots, on serial robotics, serial manipulators. So we, the lecturers, will provide the tools needed to develop your project. One thing that I must press on is that the course will be entirely lectured via Zoom. So the course is virtual. So you won't need to go to the university to assist to the lectures or to the labs. You will not need to do it. The course is entirely virtual. It will be lectured, both the theory and the practical sessions via Zoom. We're going to use the Paideia, and well, this is a virtual course. So you won't need to worry about going in a late night to the university, because you can, yeah, well, you can assist the lecture just by clicking on the link. So, and just to be absolutely clear, the course will be lectured entirely in English. So lectures will be in English, lab sessions will be in English, office hours, so assessment will be in English. And what about what? Well, yeah, I'm gonna learn a lot. But how is the course graded? So the courses are let's talk first about the contents. So in the first chapter, we're going to talk about frames of reference and vector transformations. So this is the part that we didn't tell you in dynamics course. We didn't tell you this, but the key to everything on kinematics, to everything that you've already seen, the velocity, the acceleration, the trajectories, the motion of a body, has to do with frames of reference. Once you understand how frames of reference actually work, then you will understand finally how to do kinematics. And this is not very difficult. We're going to teach you how to do forward kinematics. That is, for example, if you have a serial robot, I put some inputs into the motors that provide the motion for this robot. If I put some inputs, I will calculate the trajectory of the end effector of the robot. But we can do it the other way around. We can do inverse kinematics. That is, I want the robot to take this part here to this other point in the space. What are my inputs? How can I take a 3 or 4 degree of freedom robot, serial robot? What kind of signals do I have to put into the motors so that the robot makes a certain trajectory? And this is called inverse kinematics. How to do this, how to calculate it for a very general case, and for the special case of robotics, we are going to teach you in this chapter. So this is like the heart of the course, the first chapter. And you'll find that in other universities that lecture a similar course, that the kinematics part of this course is very, very large. And I'm not going to lie to you, this is the first chapter and this is large. In the second chapter, we are going to understand what is differential kinematics and its implication for robotics. We will finally, after all these years, we'll finally understand what actually is the angular velocity for a rigid body. Why couldn't we measure it like accurately, or why couldn't we explain it or understand it accurately when we took the dynamics course? We are going to explore and understand finally what is the angular velocity, what is the angular acceleration, and what does it imply for robotics. In the third chapter, a very interesting relationship between kinematics and kinematics will be shown. We're going to use some statics. Believe it or not, this is a way to do robotics via statics, via equilibrium, and not even dealing with acceleration, not even dealing with any inertial terms. There's a very good approximation via statics. And general expressions for linear and angular momentum, as well as the inertia matrix and its transformations, will be shown. So we are going to define a very interesting theorem, which is the angular momentum theorem, and we are going to extend it to the fourth chapter, to the Newton-Euler formulation for 3D dynamics. The Newton-Euler formulation is the most classical way to deal with 3D dynamics. This is the relation between forces, torques, and motion, and 3D motion. Don't get me wrong. This course will set you free. This course will release you from the constraints of the 2D world to the 3D real world. And this is for a single body, but we can extend it to multi-body systems. And we are going to study an algorithm to extend the Newton-Euler formulation, a very physical formulation, to the multi-body dynamics world. And why do we extend it to multi-body dynamics? Because robots are multi-body. There are multiple connected bodies via joints, via revolution joints, via sliders. So the Newton-Euler formulation will give us the tools to deal with 3D dynamics for a single body and for multi-body systems. Okay? And in the final chapter, the Lagrangian formulation, one of the most commonly and widely used formulations in dynamics, will be presented to you, as well as the virtual work principle for dynamics, and its applications to direct and inverse dynamics will also be presented. So this is what we're going to give you. And it sounds frightening. You must be remembering your old dynamics course, but don't worry about it. Don't worry, this will be very cool. And how do I pass the course? Well, this is a little bit innovative. There's only one midterm exam, just one midterm exam, which is worth 30% of the grade. The lab assignments are worth 30%, and the final project presentation is worth 30%. So what is the midterm exam? It's like a dynamics exam. Just some problems, some concepts. We're going to ask you about some concepts, some problems. You can use MATLAB, you can use your class notes to do the exam. This is a normal exam, 3-hour exam via Zoom, so you don't need to worry about taking public transportation or your car to get to the university. You can do the exam from your house. The lab assignment, what are the lab assignments? Remember that I told you that we are going to give you a practical approach. So this practical approach will be held on the labs, and in each lab, at the end of each lab, we're going to leave you a homework. And this homework, you must present it till the next lab session. So, so what about the homeworks? What are the homeworks? The homeworks are your projects. You are going to just do a little bit of your projects in each lab session. You're going to learn the tools, and your homework will be to apply these tools to your actual project. And on the final. And the final project is just the final presentation. So this is a very cool, easy to learn course. So if you want to do real robotics and dynamics, this is the course you must enroll in. And I have a question here that after this course, if one could study 3D dynamics for deformable bodies, I would say yes. I would say yes. I'm working myself on 3D flexible dynamics, but that is another thing. That is actually another thing. But yeah, this could give you a good idea to deal with 3D flexible dynamics. But yeah, well, that is another course, and someday I will lecture the course. But well, in this course we're going to deal just with rigid body dynamics. Okay, so is it really necessary for current problems? Rigid body dynamics? Yes, there are a lot of problems with rigid body dynamics, and most problems in robotics are solved via rigid body dynamics. But with the appearance of soft robotics and another flexible systems, solving flexible multi-body dynamics is becoming also necessary, but that is a tale for another day. So you practice MATLAB. It's different using, yeah, it's different. It's different. César has already taken the course, but it's a little bit different. There's a lot of programming. There's a lot of programming here on MATLAB. So we're going to teach you how to program and how to program this algorithm. So yeah, well, César has already taken the course, so he knows what he's talking about. What about Hamiltonian dynamics? Time is not enough to deal with Hamiltonian dynamics, but yeah, once we get to the Lagrangian dynamics, yeah, we're going to mention a little bit of Hamiltonian dynamics also, but there's like a higher level on dynamics that we are not going to reach on this course. Yeah. That is an open source. Yeah, it is an open source, but yeah, MATLAB is it's almost open source because many universities use MATLAB on a daily basis. So, but don't worry. Once you learn the algorithms, you can program these algorithms also not only on MATLAB. You'll find your way into C++ or C or even Python to program these algorithms. So it's not very difficult to do. So we are not going to use like a special module on MATLAB. We are going to use pure coding. So you'll be you can very well program this on other programming languages that you use or you might use. Okay, guys, so this was the presentation, and thank you very much. And well, I hope you understood. And if you understood this presentation, I think you're very good candidates to take this or any other elective course in English. So if you have any questions, you can put them on the chat. And okay, linear algebra also. Yeah, the basics of linear algebra. Yeah, the basics of matrix multiplication, matrix transpose matrix, inverse matrix. But like the concepts, MATLAB and Python will do most of the work. So yeah, we'll be very happy to see you in the course if you decide to enroll them. We have had the first time the course was lecture, we had 80 students. Last semester we had 15 students. So it's a growing population that is enrolling into the advanced dynamics course. So it's a very good course if you want ultimately to aim into robotics. So yeah. So any other questions? I have a couple of minutes, I think. I don't know if I have a couple of minutes, but well. About the first topic, can we represent any rotation, but any three rotation of any axis? Or we just have to follow the order of Euler, or maybe Bryant, or order angles? Yeah, that's a very good question. In fact, you can use any representation, any at least three angles in any order that you want, but you have to look out for singularities. And this is something that I'm gonna touch tangentially on the course about singularities. I'm gonna talk about singularities, but if you need a non-singular approach, I recommend to use 4 parameters like quaternions to do the rotations. But theoretically, you can, thanks to the Euler's theorem that we are going to see on the course, you can get from any first rotation to any second rotation through even using one single rotation around one single axis. So this is Euler's theorem. This is very interesting to do, and we'll see that in the course. I'm going to demonstrate that on the course. Okay, so I think more questions on the chat. Thank you very much, and I'll see you next semester. Bye.
Bueno, agradecemos bastante al profesor Pedro Flores por la breve introducción que realizó sobre el tema, sobre el curso de Advanced Dynamics, que como dijo, que es un curso que va aumentando en tema de alumnos y que esperemos que mediante esta charla se interesen aún más. Como ya se había puesto anteriormente, cualquier duda, por favor, al chat del Zoom, que el profesor Pedro Flores está respondiendo. Para la última ponencia está el profesor Renato Miyagusuku, que hará el tema de Topics on Advanced Robotics. Entonces le damos el pase del profesor Renato.
Ok, ¿qué tal? ¿Cómo están? ¿Me pueden escuchar?
Perfectamente, profesor.
Ok, entonces voy a empezar con la presentación. ¿Cómo va esto? Ok. ¿Qué tal? Creo que para ustedes es buenas tardes. Soy Renato Miyagusuku. Voy a estar codictando el curso en Topics on Advanced Robotics. Esta es la segunda vez que dictamos el curso. La vez pasada, el año pasado, 2021-2, si no me equivoco, también logramos llevar a cabo el curso. Bueno, un poco para que sepan quién soy yo. Soy Renato, soy peruano. Actualmente vivo en Japón, por lo cual los horarios son un poco tarde para la parte de teoría, que es la que yo dicto. Creo que, si no me equivoco, voy a hacer de 7... Para mí es en la mañana, así que para ustedes es en la noche, son las 7, 8 de la noche. La parte de teoría es virtual, es online, así que no tienen ningún problema, es simplemente por Zoom. Igual que el expositor anterior, voy a cambiar a inglés, dado que el curso va a ser dictado primordialmente en inglés. Okay, so hello, I'm going to be teaching this time also topics on advanced robotics. It's called Topics on Advanced Robotics, but we're actually dealing with probabilistic robotics. So let me see how this works. Okay. So first of all, some general information. So it's Topics about Robotics. It's 3 credits. There's going to be 2 instructors, myself, Renato Miyagusuku. I'm going to be in charge of theory. And Jorge Luis is going to be in charge of lab. So the content is 2 hours a week of theory and 2 hours a week of lab. Theory is going to be online, so it's going to be through some classes. And laboratory is going to be half online, half on a real basis. Like you're going to go to lab and actually work with computers, and we're ironing the details, but probably you will be able to work with some hardware also. So in theory, we're going to talk about probabilistic models. I'm going to introduce what I mean by this. It's a common way to work in robotics, especially in mobile robotics. That is what I'm going to teach you, and that is my main research. I'm a professor at Tsunomi University, and visiting professor in both Católica and University of Tokyo. My bachelor was actually in Peru in Mechatronics. I have a master's and a PhD degree in robotics. Well, it's technically say Mitsukoaku, but it's robotics basically. And my main work is on probabilistic models for both machine learning and robotic applications. So that's what I'm going to cover in the theory part. And on the lab, Jorge is going to work on, he's going to teach you about a little bit about Ubuntu, because that's the base operating system we use. For all of you who are not familiar with Ubuntu, you don't have to worry. It's not very difficult. Once you get used to using a command line, like typing things instead of clicking, you'll be fine. So a little bit of a little small introduction to Ubuntu, and then he's going to teach you about Python, because most of the programming in robotics that we're going to do in this class is in Python, and about the robotic operating system, which is, I think, the most interesting part of this whole class. You're going to be able to learn how to use ROS, which some of you may be familiar already, which is a very, very useful tool for developing robotic systems. Okay. The evaluations, just so you know, we're going to have 2 exams, a midterm and a final. The exams are for you to solve at home. So you will have a whole week to hand them to me. It's usually about four different problems. Some they're based on theory, and some coding may be required, but usually just one of the questions will involve some coding. You will also have a team project that you will have to make a presentation at the end of the class. Teams are going to be small groups. It's not going to be a large team. And the sessions are going to be, some of the lab sessions will have homework or will be evaluated, and that's to be decided. But there's going to be some score for the lab also. And the grade is going to be calculated as you see down. So basically, exams have a weight of 1, and then the project has a weight of 2. And the lab sessions, the average also has a weight of 1. So that's for evaluation. Okay, so what is this class about? So the class, as I said, is going to deal with probabilistic modeling for mobile robots. So probabilistic model for mobile robots. First of all, mobile robots. What do we mean by mobile robots? So a mobile robot is any robot that can move in its surroundings. It's different from manipulators that are typically fixed on a place. Like if you go to an assembly line, like I don't know, like cars in Toyota or something like that, you will see different arms manipulating the robots, the cars, and doing different works. These robots are usually fixed, like the base of the robot is fixed. We are going to deal with robots that can move. They could have an arm attached to them, but we're dealing mostly on the mobile part of it. So on the wheels, on the platform actually moving around. And in particular, we're going to focus on autonomous ground vehicles. So everything that we will teach is can be applicable to robotics in general, and basically any mobile robot. So all the programs, all the algorithms could be applied, not directly, but almost directly to like robots, for example, like Boston Dynamics robots, submarine or aerial vehicles. But all the examples and most of the explanations are going to be targeted to ground vehicles. So basically robots with wheels. So we can see some of the applications in the slide. So we have personal mobility, which is these robots basically like autonomous wheelchairs in a sense. It's a big area in research here in Japan because of the aging population. We have autonomous navigation. So these are some of the systems we developed to map and do autonomous movement, as well as intelligent agriculture. So all these three are actually examples of robots we have designed in my lab and we have access to, and I will tell you more about how they were designed and why some of the choices that were made, why we made them. Okay, so that was a part about mobile. Now I'm going to talk about the part of probabilistic. So what do I mean by probabilistic models? So a probabilistic model is one that includes elements of randomness, which sounds a little weird at the beginning. It's like, why do you want to have a system that is random? Well, the fact is that we need to incorporate this randomness because the real world has uncertainty. So it's not that the real world is random, it's more that there's noise, there's a difference between what you do on paper and what you find in reality with the robots. And we need to accommodate for that. The core idea is that if your robot is prepared to deal with some measure of error, it's going to be more robust. So it's not going to fail. If your robot thinks that the world is perfect and its model is 100% on point, when it finds a difference, when it goes to the real world and it realizes that its parameters are not correctly calibrated, or they have changed, or that the world is not as pristine as it thought it would be, or that the sensor is not as good as it thought it would be, then the robot is going to fail. So there was a big issue in the 80s and 90s. They were developing very good robots, very nice systems that even now are surprisingly good. The problem is that they basically just work at lab, like under very, very controlled conditions. They will work flawlessly. Once you take them outside, they would fail. And then is when we started to think about, I say we, but actually they, started to think about adding these kind of probabilistic models, this idea of randomness. You may have seen this in, if you have taken the control classes, I think you should have heard about Kalman filters. Kalman filter has the Q and the R matrix. They're the covariance matrices. That's the randomness. That's the belief that the sensor could be wrong, the belief that the system could be wrong. That's exactly what we're going to deal with in a nonlinear way. But yeah. Some concrete examples of why we need probabilities. So as I mentioned, sensors are noisy. Let me show you this. So this is actual data we have collected with one of the robots. This is 3D data. So 3D point clouds. We're using equivalent to VLP32. And you can see that there's some points that appear and disappear in the screen. This is a very expensive sensor, and you still get this kind of errors. You still don't have perfect measurements. They're very good, and that's why we use them. And you have relatively dense data, but you still have these spurious data, we call them salt and pepper. So even the most expensive store will have these kind of issues. And we have to be ready to deal with them. And we have the most extreme case, that is the sensors can break. They can break forever, and that's a different problem. But sometimes they just have a little bit of time when they're off, because there was some problem with the sensor. Maybe the driver goes down and then reboots or something like that. And our system needs to be able to deal with that. And we can include that kind of things in probabilistic modeling. Something else is, for example, external factors can change your system. So this is one of the, sorry, okay, let's take out the bottom. So this is our robot. These are my students at Ingeniería. They're working with an autonomous robot. We made a map in the morning, and then it started purring. It's not that noticeable in the video, but it's raining quite heavily. Why does rain matter? Well, first of all, when you model robotics, for example, you can model the basic kinematic of the robot. You will have that the wheel goes around, right? So the friction is important. If it's slippery, there's going to be a lot of slip, and that is going to affect your measurements of your internal measurements of how much the wheel has to turn, which turns into very bad odometry. There is the belief of the robot location by using this, how much it has turned. So we have that problem, for example, when it rains. Another problem we have is that a lot of the surfaces become reflective. So our sensors start bouncing, the range data starts bouncing. If you have a camera, glare increases a lot, and so on and so on. So this is another example of the system changing. So now your robot could be perfectly calibrated, your sensors could be perfect, and you will still have problems because now your environment has changed. Something else that can happen is, sorry, here you go. For example, people can get in the way. The robot has a path plan. Let's raise this. And somebody gets in the way, and the robot has to know how to react. If not, it would run over the student, and then I would be problem. And we have done this in a much more extreme case when there's like tens of people swarming around the robot, and it should be able to deal with all this. And the errors that are created by this, like when somebody like suddenly appears, the robot will have to stop, but it can also confuse the sensors, and the system has to be able to deal with that kind of things. Okay, so that's why we need robotics, probabilistic in robotics. I'm going to briefly introduce what the class is going to cover. So maybe a lot of you have seen this. It's very similar to the mechatronics diagram that everybody has seen. So this is the diagram of robotic research on mobile robots specifically. So we have localization, mapping, and path planning. Those are the three main areas. I will talk a little bit about those. And then in between is like, if you do localization and mapping, it's called SLAM. If you do localization and path planning, it's called active localization. Mapping and path planning is called exploration. If you do all of them at the same time, usually mentioned as integrated approach. So we're going to deal with all of these in the class briefly. First of all, the first 2 weeks, we're going to talk about probability theory. As we're talking about probabilistic modeling, it would be a good idea for you to refresh your probability theory. We work a lot on Bayes. So it's a little different from the frequentist approach that I think is taught in statistics in most universities. I think Catholic is the same. So we're not doing the frequentist approach, we're doing the Bayesian approach. You can search for this online. It's based on the Bayes rule. You don't need to have any prior knowledge on probabilities. It's fine. It would be a good idea if you do take, check your notes on statistics, especially what's a distribution, what's a random variable, and that kind of things, and dependence and dependent variables. We will cover all of this in class, but if you already know, it's going to be easier for you while I'm explaining it. So the first 2 weeks are about that. It's a little bit of general probability theory, not really robotics specific. And starting the third week, we're going to go directly into robotics. So we're going to talk about probabilistic models specifically for robotics. So models for robot motion. So your kinematics, your dynamics, but using probability models. We're not going to go into very complicated systems because we're only using mobile robots. We're not doing manipulators. The more degrees of freedom you have, the more complex your system will become. The approach is the same. You could apply this directly into a manipulator, for example, like the previous presenter was talking about, but in practice, it becomes a little difficult. For us, because we're a little constrained on wheel robots, that the models are much simpler, and we're going to talk about how to add probabilistic components to it. And then we're going to talk about robot perception. So by robot perception, I mean sensors. We're going to learn how to model rangefinders, so the 2D rangefinders, 3D rangefinders. We're going to learn how computer vision can be modeled also using probabilistic models. That's not a very common thing to do, but it can be done. And some other sensors like intensity-based sensors like signal intensity and magnetic intensity. Then on weeks 6 and 8, we're going to talk about 6 to 8, we're going to talk about localization. So localization is the problem that if I give you this map here on the right, the big one, and then I give you a small part of the map. Imagine this information was taken by the robot. So the robot has a rangefinder and it found this information. The localization problem is to find where in this whole map, this little part belongs. And we do this in an iterative approach. That means that the robot first takes a measurement, then moves, takes another measurement, moves, takes another measurement, until it understands where it is. There are different approaches for that. We're going to talk about some of them, the most famous ones. Markov-based localization, Bayes filters, extended gamma filters. It's not the same one you use in control, but it's the same equation. It's just the application is different from the one you've done in control. Instead of finding the measurements, like instead of using it to find measurements, we're using it to find robot locations. So the state is going to be robot locations. And then finally, Monte Carlo localization, that is arguably the most widely used localization method. And then you have your exam. Again, it's you don't have to go to class and take the exam. I will give you the exam. You will have a whole week to finish it and to send it back to me through the system, through Pandea, I think it's called. So you can find, usually you will take less than 2-3 hours to finish it. I'm giving you the flexibility of choosing when to do it during the week. If there's a programming part, that may take a little bit more, like 2 hours total. You will spend probably 4 hours, hopefully not more than that, doing this test, and you can do it whenever you want during the week. I recommend you to not wait till the last moment. I will still accept your exams after the deadline for like a week, an extra week, but every day you're late, your score gets slashed. So don't do it. Try to finish it within the week. You will have at least try to have a couple of days. Think that you will spend a couple of days on this. You can do it after all your tests are done or before your tests are your other exams. The next part is mapping, which is 10 and 11. We're going to do the problem mapping. That is, if I give you this, if I give you sensor measurements, so what the robot sees and the path the robot took. This blue part is the path the robot took when building the map. You need to find the map. You need to build the map. So that's the mapping part. So given sensor information and locations, you create a map. And we're going to do occupancy grids and intensity maps. There are like common approaches for solving this problem. Then we go in week 11 to something that is very interesting, that is SLAM, that is having to solve both problems at the same time. So you can see here the robot is, this is a top view. This is outside my university. And you can see that the robot is walking around and is getting sensor data. Just so you get an idea of range, this is about, so this is 1 block. So this is like around 3-4 blocks. I think it was like 800 to 1 kilometer that the robot was going around collecting this data up, back and forth. And as you can see, the robot is both mapping and finding itself within the map. And now you see that the map looks a little grouped, and there's like several times the same features. But now the robot will start processing it and finding the optimal solution. So you can see that now this part just became 1, it used to be 2, and it's adjusting its trajectory to match with the sensor data. So you will have at the end a very good, very precise map of how the environment looks like. I will have compared this with like aerial shots of Google Maps, and it's basically the same. It's a very strong and robust system. Okay. Finally, not finally, but the next we're going to talk about path planning. It's okay, so now you have the map and you can find yourself in the map. It's time to do something useful. So for example, you have the robot here and you want the robot to go from this point A to this point B. Path planning is involved with finding that path. So finding which is the way to go from one point to another. It can be static, it can be dynamic, and we're going to talk about the different methods to find this path. And how we could implement active navigation, that is not only doing this, but actually following through. Finally, last week, we're going to talk a little bit about design and applications. We're going to talk about how we can develop robotic systems and how we can use them in practice. Actually, there's a short class next week when I'm going to also be teaching about this kind of designs and applications. I'm not going to go into algorithms at that point, but here we will have already studied all the algorithms, so we can have a little bit more in-depth discussions about how to design these systems. And finally, at the last week, we have the exam, and on the lab, we have the team project. Again, the second exam, the final exam, is going to be the same as the midterm. You're going to have a week, and you around the same level of difficulty. It's not going to be that difficult, I think. Last time, most people got, the average was quite high, and a lot of people got like 90s plus, and even some people got 100 out of 100. So I try not to make the exams that difficult. I just want to test that you have actually understood the main components and the main ideas of the class. Just to finish this, little bit about ROS. So this is the part of the lab. You're going to learn about ROS, that is an ecosystem for developing robotic applications. The main advantage is it provides firmware. So to connect to different sensors, you just put a command line and you can connect to a sensor. To connect to robots, you have tools like visualization and logging of data, like a lot of the images I have shown you, like of the system working. That's from ROS. Like I use those tools for debugging and simulation. And finally, the community. What I mean by communities, there's a lot of open work. It's ROS is open source, and there's a lot of people like myself in different institutions working with it, and we continuously release what we have developed, what we have investigated on, so you can use it. And that's one of the, I think, the biggest advantage of ROS in that sense. So I think that's it for my presentation. Thank you. And if there's any questions, I think it's through chat, if I'm not wrong. Okay. Anyways, that was it for the presentation. Thank you.
Agradecemos bastante al profesor Renato por explicarnos un poco más acerca de su curso. Y como dice José en el chat, que por favor puedan depositar sus preguntas en el chat, o en este caso, ya que estamos finalizando y que aún se encuentran los profesores Coasaca y...
Sí. ¿Como nueva? Sí.
Si tienen preguntas, por favor, avísenlo en el chat o también pueden levantarle el micro ahorita que ya terminamos ya terminaron las ponencias de los 3 profesores. Profesor Renato Miyagusuku, ¿alguien escucha, por favor? Profesor Renato,
Sí, estoy escuchando.
está preguntando a alguien si con respecto a Topics on Advanced Robotics, si se habla en ambos ciclos.
El año pasado solamente lo abrimos igual que ahora en el segundo ciclo, así que bueno, este año también. No se abrió en el ciclo anterior, así que definitivamente solo va a ser en el segundo. Creo que va a ser la forma en la que, si es que lo continuamos, va a ser una vez por ciclo, una vez por año.
Su compañera Nicole está preguntando otra pregunta.
Sí, justo iba a leer la pregunta. Nicole pregunta, más que una pregunta del curso es sobre si fue necesario aprender japonés para poder aprender los papers sobre robotics, especialmente social, robotics enfocado en lo social.
No. Básicamente, digamos, en Japón hay ¿cómo puedo explicarlo? Si quieres saber lo último, lo más probable es que tengas que saber japonés, en el sentido de que normalmente la forma en la que publicas en general, no solamente en Japón, es normalmente vas a workshops o publicas en workshops o en revistas no indexadas, digamos, lo último que estás haciendo. Y una vez que el sistema ya está bien, una vez que ya está mejor, digamos, tienes más pruebas, más experimentos, etcétera, ya lo publicas en una revista indexada en inglés. Así que en esencia todo lo que se lee es en inglés. Hay algunos temas bastante específicos, como mencionaste, de social robots, que son bastante investigados en Japón y muchas de las publicaciones no se dan en inglés. Pero, digamos, tienes 10 papers en japonés acerca de social robots y luego combinan varios de esos y los presentan en conferencias en inglés. Hay un delay de medio año normalmente, pero sí, yo diría que no es necesario en absoluto. No necesitas japonés para poder investigar en esto. Si estás colaborando con alguien, Google Translate es genial. Yo lo uso todo el tiempo. También tenía otra pregunta de Marco acerca de que si va a enseñar ROS o Ubuntu desde cero. Sí, se va a enseñar desde cero. Les sugeriría que si es que están pensando llevar el curso, vean un poco de Ubuntu. Las instrucciones básicas siempre lo pueden instalar en su máquina como un dual boot o como un virtual machine para que se familiaricen. Yo diría más que ROS, Python, les sugeriría que lo lean un poco. Python, como usted mencionó, el segundo expositor, Pedro, MATLAB y Python son bastante parecidos. Así que si es que conocen el core de MATLAB, Python más o menos van a poder entenderlo bien y viceversa. Yo les sugeriría que lean un poco de Ubuntu, si pueden instalarlo, instálenlo en un virtual machine. Algo de Python, nunca les va a hacer daño. Python, MATLAB, buena idea. Sobre ROS, todo se va a hacer en clase, así que no, siempre es bueno ver un par de videos, pero en general no necesitan conocimientos previos.
Buenas tardes, tengo una consulta. Un compañero por Chapeo me envió si en el curso de Topics o más Robotics, cuando se refiere a small groups, se refiere a 3, 4 o 2 personas en el grupo de proyecto.
Todavía estamos coordinando eso, pero lo más probable es que sean 2 o 3 personas. No queremos tener un grupo muy grande, pero es posible que cambie, pero lo más probable es que sea 2 o 3 personas.
Eh, Mientras tanto, les voy a pasar, el profesor César Coasaca me acaba de pasar 2 libros, el libro de innovación que van a llevar en el curso de temas de Ingeniería Mecatrónica en inglés y en español. Ahorita lo estoy compartiendo en el chat. Y con respecto a otros cursos, también hay otros cursos que están abriéndose. Por ejemplo, procesos industriales e instrumentación es un electivo que se está abriendo con la profesora, que es un electivo que tiene clases y laboratorios que pueden ver que les puedo pasar el sílabus al final de la sesión. Y también está abriendo el tema de temas de ingeniería y mecatrónica que está en nos va a enseñar el profesor Félix Santos. En el caso del video del profesor Félix Santos, lo pueden ver en el canal de YouTube, ya que el ciclo pasado también se dictó. Y si tienen alguna consulta respecto a los electivos, por favor, traten de hacerlo ahorita porque ya esta presentación va a terminar y va a subirse en las siguientes horas en el canal de YouTube. Mm. El curso con respecto a la pregunta, Carmen, el curso de procesos de instrumentación, si te refieres a este curso, lo dicta Carol Muñoz. Y con respecto al canal de Asime, es el canal que en YouTube, como lo podemos encontrar en la siguiente en la siguiente parte, Asime Puk se llama el canal de YouTube.
Creo que mi internet está más estabilizado, pero si no hay consultas adicionales, más bien seguimos, por favor, síganos en nuestras redes sociales, en nuestro canal de YouTube, también en el canal de YouTube del profe Flores, que ya está llegando a los 1000 suscriptores. Y nada más agradecer a los profesores nuevamente por haber brindado esta breve resumen de sus cursos y sobre todo que estén atentos a nuestras redes para próximos eventos similares. Agradecemos bastante su atención. Muchas gracias.
Muchas gracias a todos por su participación y en las siguientes horas se enviará el video a YouTube.
Ya chicos, gracias a todos, cuídense.
Nos vemos, chicos. Gracias. Que estén muy bien.
Ok, saludos, nos vemos.